All right, welcome to today's deep dive session, which will all be about Open Policy Agent for this Cloud Native FM webinar. So before we continue, maybe just a few words about me. I'm Anders. I work as a developer advocate at Styra, which is the company behind the Open Policy Agent project, or the inventors behind the project. There are, of course, many other contributors to the project, but Styra is one of the main contributors and basically the inventors of the project. I have a background in software development, primarily in identity systems, things like OAuth, OpenID Connect, SCIM, and various identity systems. So about two and a half years ago, I started to get involved in OPA. And when I'm not working on OPA, I enjoy cooking, I enjoy food, and I enjoy football. And I have a daughter who is 15 months old. And yeah, you'll find me at the usual, just my name on Twitter, on GitHub, or LinkedIn, or what have you. So enough about me, and let's start our deep dive into the OPA project. So a good thing to start with might be what kind of problem it is we're trying to solve here. What's the challenge, or what problem does OPA solve? And the problem we're trying to solve with OPA is basically this. It's to manage policy in increasingly distributed, complex, and heterogeneous systems. So our application stacks might look something like this. And in distributed environments, we might, maybe we won't have all of these, but we were most likely going to have at least a handful different programming languages. And we're likely going to need to deploy them somewhere. We're going to need some infrastructure to run. We're going to need containers, and we're going to need container orchestration. And all of this is going to either run on hardware or in a cloud. And of course, we're also going to need data. So we're going to need data sources. So while we might not have all of these technologies in one single company or a single organization, there's bound to be at least a few of these, and probably even a lot of these. So the goal here is really to unify policy enforcement across this whole stack, and primarily the cloud native stack. So this is really the goal of OPA. You might see policy engines that enforce policy for Kubernetes, or that does it for a particular language or a particular technology. But OPA is really a general purpose policy engine. So one of the goals is to unify policy enforcement and how we work and how we reason about policy, no matter which technologies you have chosen to invest in. So again, OPA is an open source general purpose policy engine. It provides a unified toolset and a framework for working with policies across the whole stack. A core principle of OPA is that we decouple policy from application logic. So sort of like you'd decouple storage from your application and move that into a database. In kind of the same sense, you'd use OPA to decouple policy from your application logic. And when we talk about policy, it's pretty much the same thing as policy in any other context. So policy is pretty much a set of rules. And of course, we'll look further into what type of policies we might want to work with. So another core principle of OPA is that the policy decision is kept separate from the actual enforcement. So OPA does the policy decision, but how you choose to enforce that, whether it's maybe to log in some system, or whether it's to return an error code to the user, or whether to contact the authorities. That's still up to your application, because that's highly context specific. Policies, they're written in a declarative language. It's called Rego, and we'll look a lot more into that in a bit. So since OPA is a general purpose policy engine, we'll see use cases that ranges from Kubernetes admission control. You have microservice authorization or app authorization. It's kind of covering all of these different application or programming languages. You'll see infrastructure policies. That's a topic coming up more and more in recent days. Data source filtering and data source policies, who can access data and what data to return to a user based on some set of permissions. And there's also CI/CD pipeline policies, who gets to deploy what and under what conditions, and many, many more. Configuration policies, any type of policies in any type of system. That's kind of where OPA shines, and it is a general purpose policy engine. So it doesn't favor any of these technologies. It's meant to work in any field or space. So OPA is an open source project. It has a vibrant community. I think these numbers might be a little outdated by now, because there just keeps coming in more contributors and more integrations and more GitHub stars. I think it's past 5,000 GitHub stars by now, and over 4,000 Slack users. So OPA, the core OPA project is of course the main project, but there's also in the OPA ecosystem, there's a whole bunch of other interesting projects, such as ConfTest for using OPA for verifying configuration files. There's a Gatekeeper, which is an open source project for Kubernetes admission control. There's editor integrations for VS Code and IntelliJ, and pretty much all the other editors as well. Now, of course, OPA is not just an open source project, or not just some hobbyist project, but it's actually used and deployed in many of the largest organizations in the world. And one of my favorite quotes around OPA, which I think summarizes really well what OPA is about, is this one from Kelsey Hightower. So the Open Policy Agent project is super dope. I finally have a framework that helped me translate written security policies into executable code for every layer of the stack. And this is exactly what OPA is all about. So OPA and Rego, how does it work? Well, the core principle behind this, and pretty much the basis of any integration, is the policy decision model. And it works sort of like this. We have an incoming request into one of our services. And a service in this context could be pretty much anything. It could be the Kubernetes API server. It could be a Linux PAM module. It could be a microservice. It could be Kafka. The model stays the same. So an incoming request, and we can, for the case of the example, we can say that this is a microservice or an application. So an incoming request is received. So maybe a user wants to view some records from a database. So an incoming request comes into our service, and our service in turn turns to OPA and asks a policy query. It says, I have this user trying to access data on this endpoint. Should this request be allowed or not? So that would be an example of a policy query. So we send that into OPA, and the way we do that is normally through the OPA REST API. So we have OPA running alongside the service, and we send an HTTP query into OPA, and the query itself is just any JSON value. So that could include the path of the request method, the name of the user, maybe relevant groups, and so on and so forth. And OPA in turn takes that query and it checks available policies, which we have loaded into OPA, and optionally also external data that we have pushed or pulled into OPA beforehand. And based on this policy and data, it makes a policy decision. And this is what we return to the service. And this policy decision could either be, yeah, you are allowed, or no, you are denied. But it could be any JSON value. So it could be a set of obligations. It could be a set of permissions. It could be a string explaining why the user is not allowed. And in terms of deployment, OPA itself is a self-contained lightweight binary. So it's a single executable, and it's really lightweight, so you can run it in as many instances as you want. And ideally, that's really what you want to do. You deploy it as close to your service as possible, meaning you don't normally have like one big OPA covering all your application permissions need, but you deploy one OPA per instance of your application or per replica. So normally this would mean that you deploy it to the same host as a daemon, or in the Kubernetes case as a sidecar container. Applications then communicate with OPA normally through the OPA REST API. But there's also other options available. If you're writing a Go application, you can use OPA as a Go library. And if you're using Envoy or Istio, there's also the option to use specially crafted OPA binaries that are made for that purpose. Finally, there's also the option of using WebAssembly, compile your policies into WebAssembly. So it's a really versatile tool, and the deployment model allows for a lot of variation. So about Rego then, what's that all about? So Rego is a declarative high-level language. It's a policy language, so it's not like a general purpose programming language. It's not fit for writing, I don't know, 3D games or first-person shooters, but it's sort of like SQL is for databases. It's a query language, but rather than query data in a database, we query our policies, and we query them for policy decisions. So a policy is, again, it's just a set of rules. It's any number of rules combined into a single policy. And these rules, they can return any value which is valid JSON. So that could be strings, it could be lists, booleans, and so on. Rego, I think these numbers could be a little dated too. I think we have over 150 built-in functions right now. And these built-ins are also kind of tailor-made for the purpose of policy. It's not just any type of functions, but things like doing JOT or JSON Web Token verification, dealing with date and time, IP address ranges, and so on. We have a framework for doing unit testing or policy testing, which is provided as part of the OPA project. It's a really well-documented project, and you can try it out yourself without doing any downloading through the Rego playground or the OPA playground. So we talked a lot about Rego, but there was also this other component which is part of the policy decision, and that's the policy data. So if we say that, for example, an admin user should be allowed to access any endpoint, how do we know that a user is an admin? So that would be an example of data that we need. And this data can be provided in many forms. It can either be provided as a JSON web token as part of the request, or you can just with your request, when you query OPA for a decision, then you can just provide data as part of the input. So you say, I have a user here, and he or she have these roles. Should this request be allowed? In many cases, though, we might need more data than that. And for those cases, we can either push data into OPA. This could be maybe a list of all users, or maybe a list of all roles, and associated actions that should be allowed with those roles. So we can either push data into OPA, or we can use the bundle API, which basically means that OPA goes to some remote endpoint to fetch data rather than having it pushed into it. Finally, there's also the HTTP send function, which we can use from inside of our policies to fetch data at policy evaluation time. And this is really useful when we need to make sure that this data is up to date the very same second that the policy is evaluated. The downside of this is, of course, that we need to make another network call. So if you're deploying OPA into a microservice environment where you have hundreds of these services, you might want to provide that data beforehand, so you don't need to do these extra lookups. Okay, so with that, we'll start a demo. Okay, so for this demo, I'm gonna show you a bit of Rego, a bit of how to run OPA in a real scenario, how we can use OPA to evaluate policies, evaluate rules, either through the OPA eval tool or with running OPA as a server. And also we'll have a look at how we can use the built-in test framework to unit test our policies. So I have an empty directory here. I hope you can all see the screen. I'm going to open VS Code, where I'll be offering my policies today. Again, VS Code has a plugin for OPA and Rego, which I can recommend. But there's also a corresponding plugin for IntelliJ, or if you're using Vim or Emacs or any other editor, it's probably going to have an OPA plugin. So for this demo, I'm going to create a policy file, a Rego file. So I'm just going to name this policy.rego. And the anatomy of a policy or a policy file, it always starts with a package declaration. And we can name this pretty much whatever we want. Just going to call this policy in this case. And a package is pretty much like a namespace in other languages, or a package in Java or so. So we're going to name this policy, and now we're going to start to write our first rules. So what would be an example of a rule? Let's say we have an application, a microservice, or any other application, and we want to query based on some user input, a web or an HTTP request. We want to query, is this request allowed or not? So the anatomy of these rules, they look something like this. We have a name. In this case, we could name it allow. And the name of the rule is followed by a rule body. And optionally, we can also state the return value like this. So allow is equal to true if all the conditions inside of the rule are also true. So if we did something silly like this, 1 is equal to 1, then this is what we would return. And what we also can do is we can add more conditions. So 2 is equal to 2, 3 is equal to 3. As long as all of the lines in the body are equal to true, we say that the rule is true. But again, as you might remember, Rego Rego rules, they don't necessarily need to return booleans. They could return strings saying yes or no or allowed or denied. So this is just convention. But if we are to return true, this is actually the default return value for a rule that evaluates the true. So in this case, we can just skip that part and we can just say allow. So if we were to evaluate this rule, if we hop back here to our terminal, we can say opa eval, and we can say the data file here, it's the policy file we have, and we would then say the name of the rule. And the way this works is that we query for data, we query for the package name. This would be, in our case, policy, but it could be any, and then the name of the rule. So in this case, we'd say opa eval or data.policy.allow, and we'd see that the return value here is true. So all of the conditions inside of the rule that we had here, they are true. So therefore, the return value is also true. If we were to change this to something which is not true, and we were to evaluate this again, let's see that this is the rule is empty or it's undefined. So we don't get anything back now, and this might not be what we wanted. We might want to state that no matter what, we want some form of return value. So what we could do here in this case is to say that by default, allow should be false. So now if all of the conditions here inside of the rule are not true, then by default, the rule should evaluate to false. And if we do this and we evaluate again, we can see that yes, now the rule actually evaluates to false. And we could even do something like this, I think format, and we say raw. And then we only get to see the result of the actual rule and not that whole structure there. So that's basically the basic anatomy of a rule. Of course, in this case, this is a rather silly rule since it's just comparing constants to each other. So remember how we had a few ways to provide data into OPA as part of the policy evaluation, and one of those ways was, of course, to provide data as part of the input. So any data provided as part of the input, as part of the query, we can find under the global input variable. So in a microservice case, we might have something like roles. Every user has a role, and if we provide these roles as part of the query, we can iterate over the rules, and we can see that if a certain rule or a certain role is there, we might allow the request. So if we say something like this, input user roles, and in this case, we might have more than one role. So we're going to do an iteration. An iteration in Rego looks like this. And in this case, we don't really care for the index. We could do something like this. But in this case, we don't really care for if the admin role here is the first one or the last one in the list of roles, as long as it's there. So what we're basically saying here is iterate over all the roles on the user object. And if one of them is equal to admin, then this line is going to be true. And remember, if this is true, or all the lines or the statements inside of this rule is true, then the rule is going to be true. So this pretty much means that if you're an admin, then the request should be allowed. That makes sense, doesn't it? So what we can do here, if we want to test this now, how do we provide input for OPA eval? We can create an input file. We can say this JSON, and we kind of mock what an input in a real request would look like. So if we say something like this, we have an object here, and this is what we'd provide to OPA for each request. We'd say, I have a user here. This might be a username, and we could say Anders here, and the user has roles. And if one of these roles would be admin, then the request should be allowed. So now if we go back to our terminal and we evaluate this, it should by default now be false, since we have not yet pointed out any input. So let's do that. Let's say the input is in a file called input.json. And we can see that now our rule once again evaluates to true. Yeah, given that the user has the admin role, we should allow this request. Now that's of course a very simplistic rule, but it's still kind of useful. We normally have a rule like this in most applications. There's normally an admin that can do most things, and of course if I now remove the admin role from the input, and we try this again, we'll see that, yeah, now the rule evaluates to false. So now you're not allowed. So this is basically kind of the small building blocks of building policies from very simple rules and statements. So okay, one way now, the way we evaluated this now is by using OPA eval. We can use that to query rules directly from the command line, which is really useful for development, or we just want to do some quick checks. But remember, but of course the downside of this is whenever we make a change now, I need to remember to run OPA eval in order to see whether my change did have an effect. So a better way of doing this is to use the OPA, the test framework that we talked about, that I mentioned before. So in this case, I create a new policy file, and these policy files for tests, they have the same structure as any other policies, and they are in fact just Rego policies. So they also need a package name. And in this case, I'm going to call this policy test. And since this policy is in another package name, I'm going to have to import that. I could also say like, this is also in the same package. And then I could skip the import. But I kind of like to keep my tests separate from actual policy. So I'm going to name this policy test, and I'm going to import the policy package. And yeah, you might note here that we always prefix the data in front of our policy or package names. And as you might remember here for OPA eval, we also had data in front of the package name. And that's really the other global variable available in Rego. You have data, which contains all policy and all data that we provide to the running OPA instance. And you have the input variable. So it's all contained in these two global variables. So in this case, we import data policy. We might even want to import that actual rule, so we can reference that just by saying allow later on in our policy or in our tests. So how would we write a test now to test what we did with OPA eval previously? So the way we do that is we'd create another Rego rule, which we prefix with test. That's the only thing specific to tests. They are just Rego rules, but their names start with test. So we're going to test allow, or rather, we're going to say allow is false by default. Oh, sorry. Okay, so the way we could do this then, we could say allow this equal to false. Without any input provided, allow should just be false. And we can save that. And now, instead of running OPA eval to test this, we can run the OPA test runner. So we just say OPA test. And now, of course, we have more than one policy file here. So I'm just going to say dot here so it can evaluate all files in the directory. And we can see that in this case, allow is indeed false. We did not provide any input. So the user is not an admin, or we don't know what the user is because we didn't provide anything as part of the input to this test. So far, so good. Going back here, there's a little nicer way of writing this. We could actually say just not, use the not keyword to say that by default, we're not allowed. And this also, this would also work if the allow rule is undefined. So it doesn't return anything at all. So that's a good start then. And we can now know that if there's no input provided, we are not allowed. That's a good test to start with. So the next case then would be to say that if you are an admin, then we want to allow the request. So in this case, we'd say allow. And how do we provide the input now as part of a test? We could either try and source this file, of course, and use that as input. But the OPA test framework provides a convenient way of providing input. So we don't need to have an input file for each test case. But we can rather say allow with, and we use the with keyword here, which is a way of mocking input. With input as, and then we get to define what the input object should look like. So we can say user, and we can say roles, and we'll include the admin role there. So saving that, and going back here, and we run OPA test, we can see that test passes as well. And of course, we probably want to add another test where we say, where we actually provide input, deny if not admin, where we provide some input, but admin is not one of the rules contained or the roles contained. So we say developer here, and then we should say not allow. So in this case, rerunning here, we can see that now we have 3 tests passing. And of course, this saves us not just time, but it also builds confidence in our tests. And now we can run these tests as part of CI/CD pipeline or our GitHub pull requests. And pretty much any way you'd normally work with code, you can work with policies as well. So that's kind of the beauty of policy as code, and treating policy as code is you can use the OPA formatter, you can use linters or other static code analysis, and you can run tests as part of your Git commits or as part of your build and deployment pipeline. So now we have 3 simple test cases, and we now know that if there's no input provided, you're not allowed. If there is input provided, and one of the roles of the user is the admin role, then you are allowed. And if you provide input, but in the roles there's not an admin role, then you are not allowed either. And you could also add more test cases to a single test if we wanted to. So if we did something like this, again, just as any other rule, all of these statements are going to be evaluated. So if I did something like here, let's say developer advocate, and if you want to add, so you can work with kind of data driven if you so want. We can just ensure here that we are still, the tests are still passing. So that's two ways of querying OPA or working with OPA. You can either use OPA eval for simple like one-off evaluations, or you can use the OPA test runner for a more robust way of testing policies, and also, of course, to ensure that you don't have regressions creeping in later changes to your policy code. So that would be a first example. And of course, we might actually want to add a couple of rules here at this stage. So what more could there be? There could be that we have a few endpoints in this application that are considered public, meaning that if that's pretty much anyone is allowed to read those endpoints, no matter what roles they might have, or even if they don't provide any roles at all. So what we can do here is we can say that if the input request, let's say path here, is equal to public, or so, then this rule should also be allowed, or this the decision should also be allowed. The thing we did here is we just added another rule, which is also called allow. And the way Rego evaluates these policies, or the way OPA evaluates these, is if one of these allow rules are true, then the rule itself is the decision is true, or the rule evaluates to true. So while the statements inside of a body are ANDed together, we could do something like this. If this were a regular programming language, we would say something like that. We would add an AND after each line. But between rules, they are ORed. So if one of these rules, if we have hundreds of allow rules, and one of them is true, then the allow rule is true, which is, of course, what you normally want, because as long as one of the conditions are true, then that user should be allowed. So if the request path is equal to public, then the user should also be allowed. But this is a bit too specific, or a bit too exact, because what if the path of the request was something like this, or maybe pictures? We'd still want to allow that. We'd want to allow anything under the public path to be true. So what we can do here is to utilize one of the built-ins in OPA or in Rego. So I'm going to check the docs here, and I'm going to see if there's something like a starts with function. So I'm going to check the policy reference, and I'm just going to say starts with. And we can see here in this list of string functions, and maybe we should enhance this somewhat. So again, there's over 150 built-ins into Rego and OPA. So whenever you think there should probably be a function to do this, yeah, there most likely is. So we're gonna copy that, and we're gonna move back here to our editor, and we're gonna say here, so we're gonna do starts with, and we're gonna say that what we are interested in here is the path of the request, and it should start with public. So any path underneath public should be okay. And I might want to add another condition here. Just because it's public doesn't mean that anyone can just go in and delete things from there. So we might want to say, I also might want to say that input request method is equal to get. So this will be an example where we need to have both of these conditions apply. So again, we could AND these together. This AND here is implied, meaning it's not written, but that's how rules are evaluated. So at this point, we could add another test. Just check that test. Allow if read if get on public. So how would we test this then? We're gonna say allow with input as, and we're gonna create an input here. And in this case, we don't care for the user. We say that any user is allowed as long as the request is targeting the public endpoint. So we're just gonna say here request, and of course we could still add the user object here if we really want to be explicit, or if we want to be provide a full, but it would not be part of what we're actually testing here. So we're gonna say request, and I'm gonna say method, and the method is get, and the path is equal to public. And again, I might want to add another condition here where we're actually testing a subpath, where we say public pictures or something like that. Or we could add as many of these conditions as we wanted. Okay, let's clean it up here. Okay, so now we can go back and we run our tests. We say open test, and we can see that's, yeah, still the test pass, which is certainly instills some confidence. And of course, just as we did with the admin, we probably want to add deny a negative test as well. So we say test deny if not get, or if yeah, let's say not get on public. So we're gonna see here that if we change these, just gonna do some copy pasting here. I think it's warranted in this case, since we're just repeating things here. So if we do something like this, if we say put, or if we say delete, okay, then we have requests which are, by all means, they are still targeting the public path. We could do the same thing here. We say some subpath pictures, but the request method is no longer get. So these should not be allowed. So we're gonna add that not allow and not allow, and we're gonna save that, and we're gonna go back to our terminal, and I'm gonna run my tests, and indeed, we are no longer, or we are not allowed if we're sending a put request or a delete request. So that's reassuring. Okay, so next negative test we would want to add then is, of course, if you're not on the public path at all, if you're trying to access, I don't know, private, and you don't have the admin role, it might look something like this. We should not be allowed to do this. If not get on non-public. We go back, we test that, and that passes as well. So now we have 6 unit tests, and we're starting to build some confidence in our model and in our policy. And this is normally how I'd like to work with developing policies, whether they're from microservices, if they are for Kubernetes admission control, Kubernetes authorization. I like to work using this kind of test-driven flow, because not only does it provide me with a level of confidence, but it's also something that I can provide to other members of my team for review, and they can see that my policies indeed work as intended. So that's basically policy offering, some simple rules and some simple tests to go with it. So in the real scenario though, of course, we need another way of querying OPA. And if we were to run this now as a real microservice and we want to query OPA, so we can either be admin, which means we can do anything, or we have any other user querying the public endpoint. That should be allowed. Any other request should be denied. So yeah, of course, we could probably call OPA eval from inside of our application. And if we were to have a Go application, we could use the OPA Go API to do that. But in other cases, we might have an application running in, I don't know, Ruby or Java. The way we'd query OPA then is to actually run OPA as a server and query the OPA REST API. So if we did that, then how would that look like? Let's go back here. So the way we'd run OPA as a server is just we say OPA run and then we say server. So that makes kind of sense. And just as with tests, I can provide some. I'm just going to say like any file in this directory should be used when running OPA as a server. So in this case now we see that OPA is indeed running as a server, and I'm gonna start Postman here, so we can query OPA as an HTTP server. And this is of course something like this that your application would be doing. It would call OPA over the REST API. Okay, so Postman takes a long time to load for being such a simple application. Discard that, and I'm gonna open up a new tab here, and we're gonna query OPA, the REST API, and I hope you can all see this. Or yeah, we can enhance that. So okay, so the request URL here, where did we say OPA started up? It started up on localhost on port 8181. So I'm gonna say HTTP localhost port 8181, and the path here would be something similar to when we call OPA eval. It's going to be data, policy, and allow. So we want to translate that into an HTTP path. And in this case, we're going to call the V1 API. We're going to say data, policy, allow. So that would be our path. And since we want to provide input, we're going to make this a post request. And the body of request would then be, let's see here, that would be JSON. That would be a JSON representation of the input. So just as we did previously in our test where we mocked this, or as we did with OPA eval where we had an input file. In this case, we could say that input, and now we can provide the same type of input as we previously did. So if we have a user, and that user has roles, and if one of these roles is an admin role, then this should probably be allowed. And we can see that the result here is true, meaning this particular rule that we queried evaluated to true, which kind of makes sense. It's the same thing that we did previously with the OPA eval or so. But if we change this to developer or some other role, the result is now false. So this is normally how you'd query here. And if we go back to the input and we say request, and if the request method is equal to get, And the path of the request is public, and we can do anything here, pictures. And this, I think this should be true as well, because we said before that anyone accessing the public path, or a path that starts with public, as long as the method is get, we no longer care about the user roles. Everyone has access to the public endpoint. And we can see that indeed we still do. But if we change this to a put request, or really any other request method, we are no longer allowed. So that's basically 3 ways of evaluating policies. Some very basic policy offering, and 3 ways of working with OPA to evaluate policies and rules. So we have OPA eval for one-off evaluations. We have the OPA test, unit test frameworks for working with not just testing one-off, but actually test our policies over time. And we have OPA, the actual OPA server running, and how to query that. So that would be a quick introduction to Rego, to OPA, and how we can work with policies and how we can work with tests. Okay, so that was a demo of kind of the basics of OPA and an introduction to Rego, how we build policies through rules, and how we can use OPA to evaluate them in various forms. So continuing on here, what I want to do now is kind of zoom into one particular use case. And since this is the Cloud Native FM, I want to zoom in on Kubernetes and how we can use OPA to leverage policy enforcement in that context. So before we do that, we need to at least have a basic understanding of how the Kubernetes API works and where kind of OPA fits in that context. So the Kubernetes API, it works sort of like this. Before any resource is persisted, meaning like when you do kubectl apply and you say, here's my deployment, or here's my pod, and you want that to be deployed into Kubernetes, or you want it persisted in the Kubernetes database, which is of course etcd. Before that can happen though, that object needs to pass a series of modules. So that request needs to be authenticated. That's the first step. We need to identify who the user is, or who is behind, who is asking this question. And of course, once we know the identity of the user, we can authorize the request, meaning we can say yes or no. This can be, we can approve this or we can't, based on who the user is, maybe what groups they are in, and so on. After that, there's the mutating admission controller, meaning we have a chance to inspect this object before it's persisted and make mutations to that object. And there's the validating admission controller, finally. Inspecting that object after optionally being mutated, we get a chance to validate the object. And if that's approved, the object is finally persisted to etcd. So all of these modules are chainable, so meaning there can be many authorizers consulted, or many admission controllers. And there's of course a whole bunch of built-in modules that ships with Kubernetes, and I think many or all of you are probably familiar with the RBAC module, for example. And for mutating admission controllers, you have things like the always pull images controller, the full storage class, and so on. And some of the built-in validating admission controllers include the limit ranger and deny escalating exec. But what's really interesting for us, though, in the context of OPA or policy engines, is this feature of the Kubernetes API called webhooks. where instead of using one of these built-in modules, we have a chance to provide our own functionality in our own applications to either authenticate, to authorize, or to mutate or validate the request. And OPA doesn't do authentication. But authorization, mutation, or validation is all valid for OPA to work with. And the use case we're going to look into closer now is the validating admission controller. And why the validating admission controller? I'd say it's by far the most popular module to work with or to extend. And the reason that is that it allows us to build policy-based guardrails around our clusters. So some common policies to enforce include using only an internal Docker registry, or other image constraints might be that we won't allow using the latest tag for any containers deployed. Or it could be that we only want to we need to ensure that only the internal company Docker registry is used and not Docker Hub or Quay or any of these public registries, because we can't really review or audit all the images that are out there. Another common policy is to require labels. We could say that of all deployments, if you want to deploy something to our cluster, you need a team belonging. And you need to clearly mark the deployment with a label that says this is Team Ghostbusters or something like that. It could also be things like cost center or department or other organizational units. Enforcing things like ingress, host or path uniqueness is another common policy. And it's an interesting one because it's a policy that also requires data from Kubernetes to be loaded in beforehand. So we need to actually have some data provided on the current state of the cluster in order to know whether we can deploy something or not. We cannot just look at the incoming request, but we also need knowledge of what's already there. Requiring TLS for services. We could deny some insecure attributes like the host path and volume mounts. We might want to limit resource allocation like CPU or memory. Pod security policies, of course, which is another popular use case. But really anything. There's really not a whole lot of limits on what you can use for the validating admission controller. And there's basically two. What's the purpose of this? We mentioned guardrails, and I think a pretty common misconception is that this is all about security. I think it's not just about security in terms of some actor with bad intent trying to deploy something to a cluster, but I think it's just as much or even more to protect ourselves from just doing simple mistakes. I mean, if we were to deploy resources without clear ownership, how do we know 2 months later who actually owns that service? And who do we call if there's a problem? So there's a whole bunch of very interesting and valid use cases. And I think validating admission controller is, for a very good reason, the most popular module. If you want to mutate resources, there is certainly a few use cases for that as well, or even create new resources. But I think all of those, they don't really serve to build these guardrails that the validating admission controller does. So how would it look then? Again, as you might remember now from the demo, OPA acts on input. And in the case of an admission controller, it's the Kubernetes API server that provides this input. So the Kubernetes API server provides something that is called an admission review. And an admission review is basically an object describing the object which is about to be persisted. So in this case, we have a pod, and we have some metadata here on that object. We have some containers and so on, which is a normal pod pretty much. And of course, I removed some of the attributes here just to make it clear, make it clearer for the example. So a policy might look something like this. Again, we have a package name. It doesn't really matter here. And then we have a policy, and in this case, we have a deny style policy where we, instead of saying allow, we rather say deny. And as we can see here, each of these deny style policy, they have a message associated with them, meaning that if there is a deny, then we also we add a message to that decision. And when you see that message inside of brackets, it means that this rule does not just return a Boolean result, but it returns a set, and it returns a set of messages. So in this case, we would return that every resource must have a cost center label if the cost center label is missing. But that might not be the only violation of our policy. We could have many other rules, and we'd also want to include the reason why those policies should be enforced, so that the user don't have to fix one problem, try and deploy, and then get back another message. But we can provide all the messages at the same time. In this case, though, we only have one violation. So if you check the output, OPA is just going to say deny every resource must have a cost center label. So the principles are all the same. We have input, we have a policy, and we have some output. It's JSON in, it's JSON out, remember. Okay, so for the last part of the webinar, we're going to take a deeper dive into Kubernetes admission control, and we're going to look at how to apply OPA and Rego policies in that context. And we're going to use OPA to act as a validating admission controller. So let's hop right in. See here, but before we do that, let's just review again kind of the resources or objects involved in dynamic admission control. And dynamic admission control is the same thing as these webhooks that we talked about previously. So what we can see here, following like the Kubernetes documentation, is in order to configure these webhooks, we need to deploy a resource called a validating webhook configuration. And what this does here, it points to a server or a remote service which acts as the recipient of these webhooks. So in this case, this would of course be OPA. And in any of these webhook configurations, we can specify what type of request we want reviewed. And in the example here, they are pretty specific that only create requests of type pods or pod resources should be reviewed. And then there's a configuration for what service, in this case, example service, should be consulted, but it wouldn't necessarily have to be even a Kubernetes service. It could also be an endpoint outside of Kubernetes, even an AWS Lambda or something like that. So I'm not going to go deep into configuration. It's all here in the Kubernetes docs if you want to review that. One thing that we should look into then, is the structure of the webhook or the request. So the way it looks, again, I think we mentioned before that what will be passed is an admission review object. So it's going to look something like this. We're going to have a request, The request is going to contain the resource, and that's going to be like the pod or deployment or whatever it might be that is under review. So that's what we're gonna. So this is what we're gonna get handed, and this is the input document that we'll be able to use from our inside our OPA policies. Okay, and the response then, again, remember that OPA can respond with any type of JSON object. So the response would be expected to look something like this. So we have an admission review passed as input and an admission review object that is expected as output. So we'd need to respond with something like that. So going back here into our terminal, and I have some code prepared for this. One difference here is this is a lot of Kubernetes specific stuff. So it's not really interesting to review all of these resources. But what we are essentially deploying here is a few roles and role bindings for OPA, we deploy a service, we deploy OPA itself, and we also, in this case, we deploy another service called Kube MGMT or Kube Management, which is a little sidecar to OPA, which can do two things. It can mirror the state of the Kubernetes API and push that data into OPA. So we can do things like check whether there's already deployments in the same namespace, or whether there's ingress path conflicts, and so on and so forth. And the other thing it does, it scans the Kubernetes clusters for config maps, in which we can put policies. And when we do that, these policies are going to be sourced and used inside of OPA. So it's a way to provide policies to OPA. And one config map here, which is sort of static, is this one. And I don't think we need to review the whole one, but as you can see here, this object, which will be what we respond with, it mirrors this exactly. So the admission review response that is expected here is also created in OPA. And some of these values are, of course, conditional, because that's what the actual policy will resolve. So if there is reasons or not to deny requests, it's going to be in here. Okay, so far it's mainly Kubernetes objects, and there's a basic policy, but this policy only kind of builds up the base request and response handling. And the real decisions are going to be made inside of this package, and that's what we're going to build up ourselves. And we're going to get back to that in just a second. But for the sake of this demo, I created a little script which just sets up a new cluster using kind. We create a namespace, and where we deploy OPA and Kube MGMT. And the main part of all this is mainly just to set up TLS, since that's a requirement for any service serving as a webhook for the Kubernetes API. And once that is done, we deploy these resources that we saw before. And finally, we deploy the webhook configuration. And with the webhook configuration up, we see here that we want to act on all create or update requests for any API groups and any API versions and any type of resources. So pretty much we want to see any create or update requests in all namespaces, or those should be forwarded to OPA so we can make policy decisions. So once that is done, finally we'll create or we'll deploy this config map, which contains our final policy. So let's see if this works. I'm gonna run the setup script, and I would expect this to take maybe a minute or so, even though kindness is pretty quick nowadays. So let's give it some time here, and we can review this test policy in the meantime. And again, this is a deny style policy, and if you remember from before, where we wrote allow and did things like this, and then we had some conditions here in the rule body. The deny style policy works just the same. The only difference here is, rather than returning a boolean, we return a string, or rather we return a set of string, and this means return a set of strings or set of messages. And in this case, we have a very simple policy which just says if the kind that you're trying to deploy here is of type deployment, and the namespace is the default one, what we're going to add to the deny message here is, or to deny messages, is that you're not allowed to create deployments in the default namespace. So that's a super simple, not super useful, but it's a good example of, with just 2 lines of conditionals here, we can create a simple rule, and hopefully we can see that enforced. Okay, so it looks like our OPA was created. Let's check to make sure, and we're gonna see in the namespace, in the OPA namespace, we're gonna see, let's clear the screen here. We can see that we have a service for OPA, we have a pod containing OPA and a kubemgmt. We have a deployment and replica set, so that looks good. We can then check whether our policy whether this policy works or not. And in order to do that, I have a test deployment here, which is just an nginx. We deploy that to the default namespace, and then just some data. So this should fail because this is a deployment and the namespace is the default. In this case, we don't care for anything else. We just say we don't want any deployments in the default namespace. This could be maybe because each team has their own namespace, and that's where they should deploy. So let's see what happens if we apply the test deployment. Yeah, so that is exactly what we wanted. We're now getting an error back from the admission webhook saying that the validating webhook openpolicyagent.org denied the request, and we get the exact message here: not allowed to create deployment in the default namespace. That is, of course, the message that we provided here in our policy. And from here, we can add any number of similar or rules similar to that. So we can check for any of these values that we can find here in as part of the requests. We can use anything from the resource. We could check user info, groups, and so on and so forth, and then build our policy and rules around that. So this input works just the same as any input, other type of input that we'd have worked with in OPA. And just as in the previous demo where we saw the input being an HTTP request, this works just the same. And the principle applies also for things like Terraform plans or what have you. And this is kind of the part of why OPA is such a versatile tool, and why it fits in so many places. So with that short example, I I think we are pretty much done with this demo. So where do we go from here then? Where do we get started? And my usual advice is to start small. Just like we saw in the first demo where we just started with a few simple policies, we start with writing a few tests. The OPA documentation is a great resource, so use that alongside as you kind of code along to get a feel for the basics and the principles behind Rego and all the built-ins. So it's a really useful resource. And once you have a feel for the basics, start to consider possible applications near you. If you have built apps before and maybe you have authorization logic embedded in your code, then that's a great place to start. Maybe start to consider what kind of policies are already embedded and whether you'd want to extract those out into OPA. And once you identify those rules or policies, then you can start to delegate responsibility to OPA. And you can start small. Again, it's the best way of doing this. You can start maybe with just a single endpoint or maybe a single role. Maybe check if the user is an admin and have OPA make a decision just based on that. And once you see that working, then you can deploy that and you start to build experience from that. And then you can add more rules and more tests. And once you have that, you can start to consider scaling up. And OPA provides a whole bunch of management APIs and features in terms of management. I'm not going to cover all of that in this introduction, but there's a whole bunch of APIs for doing decision logging, for providing policies in terms of bundles and so on and so forth. If you want to take a deeper dive into Rego, the language, there's the Styra Academy, which is a great resource for learning Rego. And of course, if you want to interact with the OPA community, which I really hope you want, the OPA Slack is a great resource for that. Finally, there's also the DAS, the Declarative Authorization Service from Styra, which has a free edition. It's a control plane to use with OPA. And it's a great resource for editing policies, offering policies, testing policies, and finally deploying and running OPA at scale, really. So with that, I say thank you. And if there's any questions, I'd be happy to answer them after this. So thanks all.
Thanks, Andres. Really enjoyed the whole 1 hour of this. I think everybody is able to join us. Who have any question right now, they can able to ask any question. Which put them in the chat. I will throw that to Andres as well. And hope everybody liked the session as well. So I see the first question coming up that I think I also discussed this on podcast. That's OPA. People are thinking about very complex topic right now, but also they are really happy that they are doing some complex thing with OPA as well, because none of the other tools doing some kind of a complex thing with these kind of thing. Can you answer that question? I think is opening in there.
Can you repeat the question there? What was the actual question?
Actually, I'm trying to scroll through the question, and let me scroll through that. So OPA is awesome, but as we all know, Rego is hard to understand and memorize. Is there a plan to provide other options to express OPA policies in a familiar language, programming language like TypeScript or so?
No, there's no plans to do that. I think I don't think I agree that Rego is hard. I'm not like I don't really come from a background of like engineering originally, and I picked up Rego in a couple of days. and there's not that much more to learn. But I think there's a resistance in some groups. Like I think, particularly if you're more from like a ops background, to kind of learn a new language. But important to remember is like Rego is not it's not a full programming language. It's a domain specific policy language. So yeah, I don't think there's any plans to allow for other languages. But if there are things that we can improve to make it more approachable or easier, then of course we're going to do that. And we're both OPA and Rego is in constant development. So.
Yes, absolutely. And one thing I noticed that there's already pre-built libraries that are built in for these policies. And I think 90% of the time you can work with these pre-built libraries to have your work out your scenarios. And I think at the 10% of the time you have to write this Lego language yourself. So I think thanks to the community you're building these kind of libraries so you can able to use that. And I think that next question is that's interesting. Does the gatekeeper has integration with SigStore cosign for verifying the Docker image's signature and attestation? I think that's a very interesting part.
Yeah, that's a good question. And I think there's some experimental support. I know there's a couple of guys in Turkey who has worked on that. I don't think it's merged into like mainline gatekeeper, but it's definitely coming there. So.
Yes, absolutely. I think the cosign is making that attraction from the community, and I think the developer guy from the Istanbul, he's doing
right. Yeah,
developer guy. He's doing wonderful
stuff. Yeah, he's
stuff.
Everywhere in the open source community.
Yes, absolutely. I am really inspired for this work. So I won't see any other question in the chat right now. For that, we can understand. But I think many of the people like about the OPA approach of managing the policies and helping us doing the Docker things, like the Docker is also doing these kind of things on the Docker, pulling the images at the rate limiting, and you can show us the demos how you can avoid these kind of things. That's really interesting part. That's I really like about it. So I think before I let you go, the final thoughts on your OPA and what's coming up next, what plan ahead for the next year, and what are you excited about in the OPA's project, recent updates?
Yeah, I think one really exciting or an exciting track that we're looking into is like to make the debugging experience a lot better for OPA. Like, how do you know, like, how do you follow along with each line? Like, what's the current value of this statement or so? It's currently a bit obtuse. You have to kind of create external rules and evaluate them to know what's going on and so on. So we want the Rego development experience to be just as good as when you develop using any other language. And so there's a whole lot of work being done and planned for that kind of developer experience, debugging experience, and also in terms of tooling. Like we have plugins for VS Code, for IntelliJ IDEA, so on. So invest more in those tools and to improve the developer experience, and that's something I really care for.
Yes, absolutely. I think the developers, we are the targeting that they are the audience who are affected by the Kubernetes complexity a lot, and we work hard to give them a developer experience that is smoother for them. Thank you, Anders, very, very much for these wonderful sessions, a deeper dive of how to understand Rego, how to write the languages in the Rego. And thank you very much for showing it, because I think 90% of the time, I believe you won't able to write any code in Rego because there's already available libraries, and every day people are pushing these codes into the libraries, and libraries are richer and richer, and you can use these libraries. And I think 10% of the time you need some kind of your Rego code yourself. And I think another good part is that OPA community is wonderful, and Andres is also tweeted about I see this tweet. He's talking about everybody interesting to learn about OPA. Who has any question related to OPA, feel free to DM Andres on Twitter. He is a person for you, and follow Andres on the Twitter. You see that I have pinned the tweet on say you can follow Andres' Twitter handle as well. And if you have any question after the session, you can reach out to Andres on Twitter, or you can reach out to me on Discord server, Cloud Native Islamabad. We can also happy to answer your question. So thank you everyone for joining us today, and thanks Andres for sharing your time with us. It's a really enjoyable session for me. I have learned a lot of great things about OPA. Thanks everyone. Bye bye.
Awesome. Happy to hear that. Good to be here. Thanks all.